Hey guys, I'm Kant and let's learn about shallow agents versus deep agents. So now what exactly meant by the very first one, we call it as shallow agents, or we are able to call shallow agents as tool calling agents. Tool calling agents, or we are able to call them as ReAct agents. ReAct agents. So what exactly ReAct stands for? Reasoning and action. So we are able to call it as ReAct agents. And the second one we are able to look at it is called as what? Deep agents. We are able to build this deep agents using Python library called as LangChain. So they introduce this deep agents. What exactly deep agents? Let's understand. For example, if you are using Claude Code, you are able to be pretty much familiar with this what deep agents. So now why we need to understand about deep agents? So to understand about better about this deep agents, we need to understand how the current agents regularly work. Now, for example, you are trying to provide an input or you are trying to provide a prompt. So whenever you provide a prompt, basically your LLM models try to do what? They are able to generate you a response. For example, the famous thing going to be, for example, if I'm asking about what is the current score or who won IPL 2026. For example, the input prompt is what? Who won IPL 2026. So when I gave this particular prompt to an LLM model, even you can use the latest LLM models. Maybe you can use GPT 5.5 or you are able to use Claude Opus 4.8. Even these models may not be able to give this particular answer. The only reason is what? They trained on the older amount of data. What is meant by older data? They may be trained on August 2025 or they are trained on maybe like December 2025. They are unable to give a proper response. So in order to get a proper response, what these providers are doing, they are trying to connect this LLM models so with a particular thing called as what? Tool call. What is that called as? Tool call. So that cool tool call going to be what? Web search. So that tool call going to be web search. So now here LLM going to be your brain. So now whenever you give a prompt IPL 2026, so the LLM model going to decide, okay, let me perform a tool call. And it going to search the internet data. It is able to pull out all the data related to IPL 2026, who won the match. And that documents are fed back to your LLM model. Based on that, you are able to get a particular response. We are able to call it as what? A simple agent. So what exactly here agent is? It is able to perform certain actions. So now LLM model, instead of generating a response, it is able to trigger a tool call. It is able to search in the internet. It is able to get that information and it is able to perform a particular response. So we are calling them as what? A simple tool calling agents. Then what exactly this ReAct agents going to be? For example, instead of saying IPL 2026, I am asking about, for example, top three customers from Bangalore location. For example, I just asked a question, top three customers from Bangalore location. I asked this prompt to an LLM model. So now what exactly LLM model is doing? It is trying to perform a tool call. So now here in this case, the tool call going to be SQL. So now what exactly it need to do? It need to, the tool going to be a simple Python function in simple lines. What exactly this Python function going to do? It going to fetch SQL schema. So in order to write down the query, first it need to get the SQL schema. That schema is fed into LLM model. So now once it got a schema from the LLM model, now based on the schema, LLM going to write the query. SQL query is written by your LLM model. And in order to execute this particular SQL query, again you have another tool. So what exactly this tool is? SQL execution tool, or we can say an agent. So what exactly the purpose of this tool? It is able to take the query from this SQL query, it going to run in your SQL database and it is able to generate a response or it is able to generate a query. So this query is again fed, the retrieval, maybe like the top 3 customers, maybe like Prashant, Kishore, something like that. So that data is fed into LLM. So based on that, again LLM going to look at the response. So now what exactly it is doing? It is reasoning. So before I'm trying to act, so now what I need to do? First I need to get a SQL schema. So it is trying to trigger that particular tool call. Okay, now I got the schema. Now what shall I do? Now I got a schema, what shall I do? Okay, now is this schema sufficient in order to provide to this particular response? So now it is reasoning, it is acting. So now what exactly it is doing? Whenever someone is trying to allocate a particular query, first it is reasoning, it is acting, and then it is observing. It is not just trying to go in a straightforward. So what exactly it is doing? It is reasoning. So now he is asking me a question, how can I approach this? So based on that reasoning, it is acting. And after acting, it is trying to observe the particular response. So how exactly this response look like? So now is this what exactly the customer looking for? So based on that, what exactly it is doing? It is trying to provide a particular final response. Even this is also called as what? They are also called as shallow agents, or we call them as tool calling agents or React agents. So then a tool call agents, what is the difference in React agents? They are even able to observe the output, and they are able to make even refine the action. So until you are able to get the desired outcome what customers are looking for, React agents. And now this is not still what exactly companies want. Now I want to build even more in depth. So in order to build deep agents, there are 4 characteristics. If you want to really go, hey Kant, I want to build deep agents, what exactly the characteristics of deep agents? So now let's try to understand. Now let's say these are deep agents. Now in order to build deep agents, the very first one going to be, you need to have sub agents. What exactly meant by it? You need to have sub agents. So the goal is not just to have one LLM model to perform an action, or you are trying to have multiple LLM models, they are trying to work on it. So it's something like hierarchical agents. So now there is a supervisor, it is allocating work to various sub agents. So they are able to go and perform the particular action. And apart from sub agents, the another one going to be called as file system. What exactly called as file system? What is the purpose of file system? In order to track it into as a shared memory between all the agents. So in order to take the external data. So the file system works as the context between all your particular sub agents or all, even the supervisor, all of this. So that is the purpose of your file system. And the next one going to be called as system prompt. So what exactly the next one? What is the purpose of a system prompt? Is you need to say, hey, you are a this kind of agent, or you are trying to perform a coding agent, or you are a BPEC assistant, or you are a Kant assistant. So you are trying to provide all the rules, everything. So inside your particular system prompt. So that is the purpose of your, what is that system prompt? So now you have file system, you got sub agents, and you got your system prompt. And after the system prompt, the next one going to be called as planning. So now in simple lines, what exactly a deep agent's characteristics are? So every deep agent need to contain this 4 building blocks. Now if you are able to go back to React agents, now it is able to perform a tool call. There is only one particular agent. It is doing the entire action. So this particular React agents doesn't has sub agents. It is able to plan. So now in the React architecture, it is reasoning, and then it is acting, it is able to plan. But before that, maybe like plan and act architecture. So it is able to plan all the steps. So who need to work, which sub agent need to work, that is not really there in your React architecture. So React architecture is more like I'm working as a freelancer, or I'm working as a consultant, or I'm working as a self-employed. So what I do, I reason, what shall I do? And I am the one who is reacting to it. So I'm thinking, I'm reacting to it. I'm thinking, I'm reacting to it. I'm not allocating work to anyone. Let's say maybe I own a company, then I need to plan. So like, what is the role of each and every particular employee? So what exactly they are doing? They need to report to me. I need to observe what they are doing, and I want to parallelly allocate them, or I need to change it to other employees in order to get the work done. So now this is also lacking in your React agents. Now what you need when you are trying to build your deep agents, you need to have various sub-agents. So when you're having sub-agents, in order to see what is the progress happening, there need to be a shared memory. We are trying to record it in file system, and apart from it, if there is any external company documents or if there is any files, PDFs, etc., all of this need to be fed into agents in order to understand. So they act as what? Context. And apart from it, before I'm going and doing it, you need to plan all the steps. So the planning is very important. So based on the planning, you are allocating the work to agents, and based on that, you are, for each and every agent, you are trying to provide a proper system prompt, how exactly you need to behave, what to be done, so to whom you need to report. All of that steps is recorded with the help of system prompt. And finally, in order to provide a data or the memory, you are having your file system. So these are the four characteristics. So how you can build this deep agents? For example, if you take Claude Code, yes, they develop the deep agents with the help of these four characteristics. Yes, I want to build the deep agents. Can I do it? Yes. If you are able to include these four characteristics in any agent, yes, they can be called as deep agents in simple lines. Now, if I want to go and if I want to develop these deep agents, how you can develop it? I want to go and I want to build this deep agents. So how you can build it? One way, if you want it, one of the easiest way, you can build it through LangGraph library. You are able to build it through what? LangGraph library. Now this LangGraph library is a pretty much low level API. So what does it mean by low level API? You have more granular control towards how exactly the things to flow, how exactly what type of memory to allocate. Everything you are developing it from scratch with the help of LangGraph. In case no, so even this LangGraph is from who? This is from LangChain framework. Not really, Kant. I don't want to build it that granular control. I want it so easy. Then you are able to use deep agents. So even LangChain people build these deep agents using LangGraph itself, but it is even more easier. It is pretty much high level. With a very less amount of learning curve, you're able to start building deep agents. It's very, very easy. So building that is very, very easy. So if you are calling any deep agent, for example, you can simply say create deep agent. And if you just need to pass an LLM model. So now the default within this deep agent, it's going to contain planning. It's going to contain a system prompt. It's going to contain ability to handle subagents. It is able to have even a file system or a shared memory in order to communicate with each other, in order to have a track of each other. So within this file system, again, you have a short-term memory and a long-term. All of these are part of your deep agent. So that beautiful is your deep agents. We can say like it's a bit add-on to your lang chains in order to build agents even more easier. Even more complex automations can be built with a very less amount of programming. So now if you have a lot of programming, what happens? There is a lot of friction. Everyone can't go and build the agents. There is a lot of time to do it. Now, by mastering deep agents, what happens? Anyone can go and build it using Python programming. You can start building multi-agents or hierarchical agents, maybe like within 5-10 minutes. That is the power we have in deep agents. Now, I hope you got a simple understanding between what is deep agents and what are shallow agents, and within that what is tool calling agents, ReAct agents. I hope you got a simple idea behind it. Now let's try to see how exactly we are able to start building one small deep agent using Python and through your LangChains library. In case if you want to build it through N8 or so, very simple. Any deep agent has only 4 functionalities: sub agents, which need to have a hierarchical concept, system prompt, what exactly each agent need to behave, a planning, proper planning. Before you are going and hitting a particular task, you need to plan, and then you need to have a proper file system, or we can say memory or a shared memory, in order to have the track of everything what you are trying to do. That's it. So now let's try to get into the hands-on. Let's see how exactly we can build a small deep agent. Let's build one simple deep agent. So in order to build a small deep agent, let's open VS Code. Now this is my VS Code, and for I want to open a folder. Let's click on the folder. Let's me go back to script files. Let me create a new folder called as deep agents underscore tutorial and say open. Now here I am in my folder structure, and the only very simple the only reason I use a folder structure is if I'm able to install, if I create a virtual environment for this folder, it going to run any point of time. So there is no problem for me. That is the one of the major reason I separated. And not only that, when you want to include that with a front end and a back end, if you want to run it as an application as well, so having it in a folder, keeping all the files related to that particular application going to be one of the best practice. And now the very first step is what? For example, in order to set up your project structure. So in order to have a project structure, I will be using UV in it. So UV is one of the very good library, powerful library. If you want to, it's more like a package manager. If you want to install the libraries using pip, it may take some time. So setting up the project structure, creating an environment, everything going to be so quick with the help of UV library. So now that's one of the reason I'm using UV. And in case if you don't have UV, you can simply say pip install UV. You can simply say pip install UV so that you are able to install it. And after installing UV, now I want to have a project structure, simply say UV in it. Now I created my project structure. So now here you got couple of files. One is called gitignore file. So now you created all the script and you want to push this code into your GitHub. Now you don't want to push all the files which are available right here in your VS Code. You want to skip some of the files. So for that reason, you will be including those files in your gitignore. Now let's say I will be creating virtual environment. Even I want to exclude virtual environment. The reason why virtual environment file size itself going to be so big. So there is no point in pushing that entire thing into your GitHub, so that we are able to include certain files or the folders so which need to be excluded while I'm pushing it into GitHub. For the sake of version controlling, you will be using what gitignore file. And in order to, maybe if I want to go create a Docker image or if I want to run it on the cloud anywhere, I want to know what is the Python version currently I'm using. And normally when you are having multiple files, for example, let's say you got a backend files, you got your API files, you got your front-end files, all of them you try to trigger it from your main.py in case if you have multiple files. And pyproject.toml is your project file which gives you the name of your application, the version of it, in case if you have any description, any readme file if you have. Normally having a readme file is good. Now you created the application, you moved out of the organization, you came back, maybe after 5 6 years, maybe some other guy is working, so he go through readme file, what exactly you have done and what version you used it, what exactly the purpose of this application. So everything going to be more easy. So they are able to understand everything through this pyproject.toml and readme.md file, and require what exactly the Python version. And in case if there are any libraries to be installed, you can include them here under dependencies. You can simply say uvsync, or you can have a requirement.txt. We will be doing it. Before I'm going and doing requirement.txt, I can simply say uv when we, if I want to create a virtual environment. Now I want to create a virtual environment. To activate it, copy this link and paste it. And remember, in case if you are a Mac user, so if you are a Windows user, I'm doing this in Mac. In case if you are a Windows user, you may not get the same thing like source.venv. You will be having a separate link. You get some other link. Try to copy that and paste it so you are able to activate the virtual environment. Currently, base is my actual over global path. And when I gave deep agents tutorial, so that is my virtual environment. Now currently I'm in my virtual environment. So all the libraries in my system, they cannot be accessed to this virtual environment. Now in order to run any files, I need to have a particular library. So for that, what I'm doing, I'm trying to have one particular file called as requirements.txt. So I need to have requirements.txt. So now here I will be having certain requirement files. So now few libraries are important. The very first library is called deep agents. So this is a library from LangChain itself, deep agents. Another one going to be LangChain. I will be using LangChain hyphen OpenAI. I will be using an API key from OpenAI to access my LLM model. And then I will be using Tably hyphen Python in order to perform web search. And one more I will be using is IPY kernel. IPY kernel, and another one going to be, I will be creating a environment variables and I will be importing that. So if I'm using I means like API keys in my script, what happens, they're going to be exposed, and when you're pushing that to GitHub, automatically those API keys going to be deleted. So we don't want to do it as a best practice. So now I'll be storing them in an environment variable. So I'll be simply say .env. So these are the kind of libraries needed from Python. So simply say Ctrl S, and in order to install them, the command is simple, uv add hyphen R. R stands for read the requirements.txt. So let it install. Yes. So as I said, it's rapid fast. It is able to install all the libraries. So once you got all the libraries, now IPython kernel, IPY kernel is if you want to open or if you want to open Jupyter Notebook and if you run it, it's going to give you IPY kernel going to give you all the computational engine. That is the purpose of it. Now I got all the libraries. Well, now the next step is let me try to, before I'm creating it, let me create a simple folder structure. For example, here I want to create an app. Before I'm creating an app, let's say I want to run it on any Jupyter Notebook, I can simply say tutorial basics underscore tutorial. That is a folder. Let me tutorial, and within this I want to create a IPYNB IPython notebook. Yes, I got my IPython notebook. And if I click on the code, you're able to start writing your commands. For example, to test it, if you want to test any commands, you're able to see. So from Langchain underscore OpenAI. So I want to select the kernel. So let me select the kernel, Python environment. So this is the kernel. So deep agents. So OpenAI, import chat OpenAI. So shift enter. Yes, we are able to import the libraries, means yes, we are able to successfully install the libraries. And after that, I need to have an environment variable. The reason is I want to have certain API keys in order to use the LLM model. So I'm creating .env file, and the command is very simple: OpenAI open underscore OpenAI underscore API underscore key, and I want to create key, give my key. So I always store all the API keys at one place like this in a notepad. Let me copy the API key. I'll be showing you also how to create an API key. And after this, I will be using web search. So for web search, I will be using Tavli API key, and let me copy Tavli API key as well from here. Yes. So these two API keys are something very important. One is OpenAI API key, another one is Tavli API key. And how exactly we can create it is one, go to OpenAI. In order to use OpenAI, you need to have OpenAI account. So very simple, login, API account, API platform, any Gmail account is fine. And once I signed in order to start using the APIs, you need to have certain balance. For example, no Kant, I don't have any, I don't want to add any balance. For free, you are able to use it through Grok, or you are able to use it through Gemini, so that you are able to use it for with free without paying any money. Normally, I'm using OpenAI, which is like $5 prepaid balance. It's not like postpaid. It's like a prepaid. So whenever it got completed, you can just add through your credit card and go to API keys and simply create your API keys by clicking on this tab, create new secret key. And the same way, if you want to get Tavli API key, simply so go for Tavli. This is your Tavli, and the same login. This is for web search. So now whenever you ask a prompt, you need to search through the internet and it need to give a response. Yes, Tavli is one of the best option you have. And same, sign in with your Gmail and go to your API playground. No, settings. Yeah. So if you go to overview, you can simply create API key from overview. That's it. You can give any name of your choice and simply say test. And for development sake, simply create. You're able to get the API key, you can simply copy the API key, paste it at one place in a notepad. That's it. So once you got your API keys, you are adding them in your .environment variable. And after adding it, if you want, you can simply say Control S. I always use this as a practice. Sometimes doing a Control S, if you miss Control S, and you just try running it, sometimes it may not detect the changes you made it and you are unable to do those operations. So let me just close the environment variable, requirement done. Now I just have the basics.py, and here I will be start doing certain operation. The very first one going to be, I want to load the environment variable. So how you are able to load environment variables? Very simple, import OS. Another one going to be from .env import load underscore .env. And once you have this two stuff, now in order to get the environment variables, you can simply say load underscore .env. That is sufficient. And if you want to really import anything, now you can simply say, now you already got this one. What is that? From Langchain underscore OpenAI chat OpenAI, you can simply say LLM equal to chat OpenAI, and I'm able to give the model name, model equal to GPT hyphen 5.4 hyphen mini. And if you want to give any temperature, so temperature purpose is what? Now when you are giving temperature 0, your model is trying to be deterministic. When your temperature is trying to be 1 and 2, your model is trying to be more probabilistic in nature. What is meant by probabilistic? For a given input, it can give varying responses. So if your model to be more creative, we call it as deterministic. If your model need to be more we can say like it need to give the exact answers every time. For a fixed input, it need to give exact answers every time, or it need to be more for a Q&A or a fact check. Your model need to be deterministic, where your temperature value need to be around 0. And I can simply say 0 and shift enter LLM equal to chat OpenAI. Now see, I just use load underscore .env. Some of the libraries can automatically detect the API key. Now if I just simply say LLM dot invoke, if I ask question, what is agents, and if I just run the command, it going to start giving a response. It going to detect the API key, but some of the commands cannot automatically detect it. So in that case, what you can do, you are able to start giving this command os dot environment. For example, this is already written. So now OpenAI API key as get environment variable. So now from the environment variable, get this OpenAI API key and get it into this particular stuff. You are storing into OpenAI API key variable. And the same way you want to get the Tavli and you want to load it. So now by using this command, what happens? You are pulling out the an OpenAI key, Tavli API key from the environment variables, and you are trying to have it in this variable with the name OpenAI API key or Tavli API key. So that would be more easy in order to provide it. So the reason is very simple. Some of the functions don't support automatic detection of the API key. For that reason, you are trying to call this to, or if not needed, you can simply say load underscore .env. You are able to get the stuff here, the API keys. And now I want to build, as I said, what exactly I want to build? I want to build the deep agents. So before I'm building deep agents, what we can do is let's build various tools. I'm trying to build various tools. So the tools going to be, you are able to use any web search tool and all of that. So for example, if you want to build any deep agents, it's very, very simple. So let me try to build a simple tool. Define, I'm calling it as calculator, and I can give expression. What is that? I'm giving a string. So now, and for a string, whatever I'm giving as an input, you're getting given the string as the output. Now this is what I'm trying to do, and let me try to give a small doc string. The purpose of the doc string is you are trying to say, means like these tools are fed into your LLM model. Now your LLM need to know what exactly the purpose of this tool. So now in simple lines, what I'm doing it. So now safely evaluate a basic arithmetic expression. Example, for example, let's say I want to check it, safely evaluate an arithmetic expression. Example, let's say if I'm trying to check for a car price, let's say 89.6 lakh, if it is a car price, or maybe like 40.6 lakh of a car price. In order to get a GST amount, what I need to do, I simply need to multiply with 0.18. That's it. So safely evaluate a basic arithmetic expression. Example 40, just I gave a small doc string. So whenever we are feeding it, it going to. And after that, I want to write, this is just a doc string. Now I want to write actual logic. So what is there? So now within the allowed, what is allowed in the calculation? So I'm providing set of what are all the allowed thing. You can do numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, You are allowing plus, minus. You are able to allow multiplication, division. You are able to allow, yeah, dot, decimals, braces. That's it. So these are all what allowed. And that's it. I think we're able to provide this allowed. Let's try to see how exactly it works. Or we can give some sort of means like if the C is not working, we need to give a error message. Let's say if not, so now if not, so set expression, whatever he is feeding is less than or equal to allowed, return error, only basic arithmetic is allowed. Try return. Yes, this is good. We are able to give the feed this. And in order to test, in order to build any agents, so now deep agents, simple from deep agents import create underscore deep underscore agent. Let's load this library. Yes, we are able to load it. Now I can simply call, we already have an LLM model here. It's LLM. Now I just want, in order to build any deep agents, you can simply say agent equal to create underscore deep. Now what I need to feed in within this, what are the arguments allowed? Now I need to provide tools. So what are the tools? Calculator, which I created, is the tool, and I need to provide system prompt. System prompt going to be, you are a BPEC assistant, use tools when needed, and I need to give model equal to LLM. Now here comma and system prompt comma. Yep. Now I can simply say result equal to agent dot invoke. Let me, it expected a dictionary. All right, let's feed a dictionary. Now invoke, let me try to feed it curly braces, messages, curly brace. Let me give a role, and the role is user, role user, comma, another key, content, and the content is if a BMW X5 is 89.8 lakh on road, what is 18% GST portion. Let me close the, already closed here. Result of messages first last index and content. Yep. You're able to see the GST portion is about 13 point something. It is able to start providing 13.70 lakhs. It is able to start using that particular tool and it is able to start giving a response. So now this is how we are able to call one simple agent. Now in the similarly, we are able to start defining other agents as well. For example, I want to look at maybe like an internet search. It need to go through an internet and it need to perform an action. So to perform an internet search, what is needed? You want an internet agent or you want an internet tool in order to search through the internet. So very simple. Let me define internet underscore search and I want to provide a query which going to be string and max underscore results integer and the output also need to be, is there a need to define output? Not needed. The output may vary, it can be a string or it can be anything. Now let me write the doc string search the web. So in simple lines, doc string work like a prompt for your LLM, current information on a topic and use for any question that needs up to date facts, trends, or competitor or market information, something. And what exactly this need to do? Let's try to write it. So return tably dot search. You are trying to feed the query equal to the query, the user query or feeding. Max result equal to max underscore results equal to max results. How many times you want it. So you created a simple internet search tool. Now within this search tool, what I need to do, I want to create an agent. So I'm calling it as research underscore agent equal to, so create underscore deep agents. I want to provide tools equal to internet search and I want to provide system prompt. You are an expert researcher, always use write underscore to dos to plan, as it is able to plan first step. And the next one to use internet underscore search to gather facts. 3. Save findings to file. And 4. Write a clear final report. So this is a simple system prompt. And after the prompt, yes, you need to provide model equal to LLM. You are trying to provide. This is the agent we called. Now let's try to invoke message equal to research agent dot invoke. And I want to use the same structure of this in a dictionary format. So now message role user content research top 3 trends in deep agents 2026. Yeah, that's the prompt which I gave. And let me run the response. Name Tavli is not defined. Right, brilliant. Here I have done this. Now I haven't imported Tavli client. So simply from Tavli import Tavli client and Tavli equal to Tavli client of API key. Yes, this is the one. Now this is not needed. Let me run this. Once I got the response, same thing. Yep, you got the response. Now, instead of result, it going to be out. And let me use a print command. So print of. Yes, it is able to pull out top 3 trends in deep agents for 2026. Now, this is how we are able to, and let's see, is it able to really pull out the content or not? Is it created any file? Let me run. Yes. So it is able to load this information. It is able to save it in the file. Deep Agents 2026, research notes, scope, research focus. It is able to create it as a notes. So now, as I said, so now this is having the basic steps. The basic steps are what? So now the 4 sub blocks, it is able to think, which is like planning. It is able to start having a subagents. If we can define even subagents, and apart from subagents, the next one going to be, it is able to have the system prompt, and apart from the system prompt, it is able to have a proper what is that, planning, subagents, system prompt, and your files. All the 4 are available. So now this is files, and it is doing the planning, and the subagents is not done, and we are able to provide a system prompt. And if I want to see how exactly it is doing line by line, if I want to understand, I'm able to simply use this. So for chunk, in we build the agent. What is that agent? Research agent. So for chunk in research agent dot stream, if I want to see what exactly happening, the line by line output. So stream curly braces messages. Yes, I want top 3 trends in the agents. And stream underscore mode equal to values in order to see what is happening behind. And I can simply say chunk of messages -1 dot query underscore print. Now we are able to see how exactly it is able to perform line by line identification, AI message, tool message, AI message, write to dos. It is able to perform the action. So this is how we are able to notice it. Now let's build a small subagents. Let's see how exactly we can build the subagents. So to build subagents, we want to look at a few more tools is needed. Now we have research tool and we got calculator tool. Let's see, I want to perform a keyword identification. Let's say I'm working for a marketing company. I want to build some blog writing, or I want to identify the right keywords for the Google ads. So for that reason, I'm using this function called as expand keywords. Expand a seed keywords into long tail variations using common modifiers. For example, if I give one keyword, you need to make different varieties of it. For example, now I asked for AI, artificial intelligence. So the modifier is going to be AI course, artificial intelligence training in Bangalore online. So these are all various modifiers. So if you are giving one keyword, now you want to modify various varieties of keywords. That's what this particular function is doing. And after doing it, there is another keyword called as another function called as classify intent function. So what is the purpose of this tool classify intent? Classifies a keyword search intent as a commercial, informational or a navigational and assign an add priority. So now it is trying to look at free, salary, what is versus meaning. So now this is taken as what intent, informational, add priority, low. For example, someone is searching for fees, course, training, certification, placement. So the intent going to be what? Commercial, add priority is high. And in the similarly, so now navigational, add priority. In this way, there are different varieties. So the rest of all going to be navigational, add priority, medium. So this is what we are trying to do, classify function. Now based on the keywords written, it is able to segregate into this. Now what exactly I want to do is, I want to connect all of these particular tools. So how exactly I'm able to connect all of these tools? I'm able to connect them with the help of various subagents. For example, look at this. Now I'm trying to call. Now, first there is a research subagent. So now research agent finds seed keywords by researching the topic, so on and so forth. You attached the tool. Next one is expansion subagent. Again, you gave the tool expands keyword and classify subagent. And this purpose is for your system prompt in order to what exactly the purpose of this particular agent you are giving that. And supervisor. So create deep agent. You provided the tools, internet search, expand keywords, classify intent. System prompt, you are a supervisor of a Google Ads keywords team. Use writing to dos, then delegate, so on and so forth. You gave your LLM model, subagents you provided, and this is the output supervisor dot invoke and message is equal to role user find ads keywords for an agentic AI course in Bangalore page. And if I'm able to run this, now it is able to trigger the agentic behavior. It going to perform the action. It going to take couple of minutes to do this. Yeah. So it is able to complete the particular action. It is able to give you the steps by using subagents. Now this is one of the beautiful example where it is recording the memory. It is able to use subagents. It has system prompt and it is able to use your planning. All of the steps are included. If you want to really look at the files which are available also, you are able to look at the files. So now I showed you earlier how exactly to look at the files. The same way we are able to look at the files as well. So now this is how we can build subagents. You will be seeing more sessions or more videos on subagents. And in case if you really like this or any doubts, please share your views in the comments below. Thank you.